Okay, here we are, Mission 9, Force Analysis. We have several things to calculate. Remember, there's a table of contents at the end of the video, and remember that the physics classroom also offers help on these problems. So I'm going to do the problem out, but pause the video and do it yourself first, and then compare what you did to what I get. Okay, the first thing I did was to calculate F-grav. Notice I call it FG. I wrote the equation. I wrote the numbers with the units. I didn't write the answer, but it's 10 times 1200 is 12,000. And then I know that F-grav and F-norm are equal. And there's only one unbalanced force, the force of resistive force, or friction. So that goes here. That's also the net force, because that's the only unbalanced force. And the mass is given, and if we divide the net force by the mass, we get the acceleration. Okay, let's check that. Okay, do the same thing. Get your answers before you look at my answers. Okay, for this one, I just wrote down all the given information first. 400 for the applied force, 50 for the mass, 2 for the acceleration. Then with the mass, I got the force of gravity and the normal force, which has to be equal and opposite because there's no acceleration here. And notice I'm showing you the formatting because on a quiz I may ask you to show your work. Write out the equations, the numbers have units, answers have units. So just notice the format and practice that. So then we're left with finding the friction force and the net force. Since we know the mass and the acceleration, since we're given the mass and the acceleration, we can use that information to find the net force. That's 100. And since the net force is 100, we can use that to find the friction force. If the net force is 100 and this is 400, logically this is 300. This problem, you could actually do it in your head, but be sure that you are able to write all this out in a situation where you're going to be asked to write it out. Let's check our answers and hope that all those calculations are correct. Okay, since this is identical to the first problem we did, I'm just going to give you the answers and then move on to the next ones. But pause the video if you want to practice. Pause the video and see if you can get the answers. Okay, there are the answers. The F net, we're given the mass and the acceleration, so that gives us the F net. And the F net is equal to the F fric in this case, since it's only one force. Let's check our answers. Okay, here the two forces aren't equal. We're given the tension force. With the mass, we can calculate Fg, or F-grav. The difference will be the net force, and the net force can be used to find the acceleration. Whoops, I didn't put that in. Let's check. Okay, don't be fooled by this one. It's a constant speed, so that means that the net force and the acceleration is 0. The mass is given. From that we get the gravity force. And since the acceleration is 0, the tension force has to be equal to the gravity force. Okay, notice I use a slightly different notation. Like I use sum of the forces instead of F net. And I use Ft and Fg instead of F-grav and F-tens. Anyway, we put in what we're given. From the mass we get the gravity force, and the mass and the acceleration, the mass times the acceleration gives us the net force. There's a net force down. I'm not putting in a negative number. I hope that's right. And the tension force has to be the difference between the two. But strictly speaking, the gravity force is down, the net force is down, and this is positive. Let's just see when I check it if the numbers get rejected for not having the negative signs. Okay. So we're given most of the numbers. The applied force is 50, the friction force is 20. That means the net force is going to be 30, and 25 kilograms gives you a gravity force of 250, and the normal force has to be equal and opposite. The mass is given, and from that we calculate the acceleration is the net force divided by the mass. I didn't write that out. So the 70 kilogram skydiver will have a gravity force of 700. Since the resistive air force is 490, the net force down is 210. And if we divide the net force by the mass, we get the acceleration. Okay, here we are in mission 10. Answer the question and come back. So read through all the statements and reject the ones that are wrong. Finding the wrong ones and identifying why they're wrong is an important part of your learning experience. Anyway, the correct one is D. The ratio of net force to mass is the same for each, and I'm showing you that like in symbolic or equation format. So the acceleration will be the force divided by the mass, and the force acting on a free fall object is the force of gravity, negative mg, divided by m gives you a negative g. So it doesn't depend on m because the m's cancel out. So that's the symbolic or equation way of looking at this problem. And checking the answer. Okay, question 2. See what you remember about projectiles and projectile motion. So first of all, let's do it in our heads. So we know that things fall rounded, negative 10 meters per second. So if they fall for 4 seconds, it's going to go from 0 to 10 to 20 to 30. It's going to end up having a speed of 40 meters per second. We can find that using the standard equations as well. And if it ends up at 40 meters per second, that means it's averaging 20 meters, going from 0 to 40, averaging 20 meters over 4 seconds. That would be 80 meters. But we can also use our equations to solve that. So I'm picking equation number 3, delta y. Notice I changed the x's to y, so delta y, that's 0. 1/2 using 10 as the acceleration gives us the 80 meters per second. And so it's 40/80. Okay, those are the correct statements. Go through them one by one and convince yourself why the correct ones are correct and the incorrect ones are incorrect. Okay, this is a good question. It'll check your understanding of projectile motion. So what's true of projectile motion is that the force is only the force of gravity, so that's 2 times 10. So the force is going to be 20 newtons, and that's going to be constant, right? And the acceleration is negative 10 meters, or in magnitude 10 meters per second. So the correct answer is this, right? Although the velocity is 0 at the top, the acceleration and the force are constant throughout, whether it's going up, whether it's at the peak, or whether it's coming down. Those are the magnitudes of those two values always. So all statements are false except for B. Convince yourself why the other statements are false. And here's the symbolic or equation solution. The acceleration is the force of gravity over the mass, but the force of gravity is mg. And so for any mass, that ratio is going to be g, because the mass, no matter what the value is going to cancel out. For a longer explanation of this problem, go back to minute 8:04 where I explain it in more detail. But anyway, an object falls for 2 seconds. From 0, it's going to go -10, -20. And the distance, because it's averaging 10 over 2 seconds, would be -20. You can also use the kinematics equations. I explained that in more detail back at that time where I solved the problem previously. The only correct answer is B. You should read through the others and understand why they're incorrect. So they do have the same g value and the same acceleration. They have the same acceleration and the same g value. The rate of acceleration is the same despite their masses. That's the correct answer. They experience the same force of gravity. No, they experience the same acceleration, but different forces of gravity. And that's not true either. So 5 seconds of falling at a rate of 10 meters per second will give you a value of 50. You could use this equation to get it. The distance, I just picked kinematics equation 3, change the x's to y's. You see how that works. And v initial 0, and so the distance is this. And it gives me 125 meters, so H is the correct answer. Actually, I'm not sure about this one. Certainly this is true, but there's another condition of air resistance, so anyway, I picked true. If it ends up being false, it's because they didn't mention no air resistance. Let's see if it's accepted or not. Okay, so they did want that condition of air resistance in there. Is an essential condition of projectile motion or free fall. So we should have guessed false on that one. Too late. So the condition is no other force other than the force of gravity. So that's the only free body diagram that works. So this does meet the condition of free fall. It doesn't matter that it's rising. So the statement should be true. I mean false. So G stands for the 9.8 meters per second is the acceleration due to gravity. Okay, next mission. Okay, now we're going to allow for air resistance and look at problems where air resistance is a factor. So answer the question. And so since the object is in terminal velocity, that means constant velocity, that means no acceleration. The two forces have to be equal and opposite. So object B and object D fit that description. Increasing speed means increasing air resistance and increasing air resistance means that the net force gets smaller and smaller, so the acceleration decreases. So increase, decrease. Okay, read this over carefully, see what you come up with, and then come back and see what I'm going to say. So this one's a little harder than it first appeared, at least to me. So we want to rank accelerations. Acceleration is the net force divided by the mass. So the first thing I did was to find the net force. And we're doing magnitude, so it doesn't matter whether it's up or down, but these are all down anyway. And so the net forces are that way, but notice the masses are different. And how can we tell that from the force of gravity? So the force of gravity using 10, this would be 55, this would be 80 kilograms, 90 kilograms, 100 kilograms. And so I divided those masses into the net force, the difference between the up and the down force, and these are the numbers I got. So that gave me this ranking. Let's check it out. Okay, we did the calculations right. Next. Okay, for learning purposes, we want to understand, not just identify the right answer, but understand why the wrong ones are wrong. So terminal velocity means acceleration 0. So that's not true. No, there'd be no air resistance if it stopped moving. The net force on the object is 0. It's not accelerating. No, that would leave you with an acceleration. Velocity is not changing. No, you wouldn't have terminal velocity if gravity were the only force acting. And no. So only one correct answer. So air resistance is related to velocity. And if objects have the same dimensions, the air resistance is only going to depend on the velocity, right? Because it obviously depends on the size and the velocity. So all objects of the same dimensions will fall at the same rate regardless of their mass. Clearly, a balloon and a bowling ball of the same dimensions aren't going to fall, so that's wrong. Lighter objects will fall. That seems counterintuitive. Now, heavier objects, the bowling ball of the same size as a balloon, will fall faster. So clearly the net force is up. The person's going down because they're just pulling the parachute, and so they're going to be slowing down if there's a net force up. Whoops, I lost the screen. Anyway, there's a net force up and an acceleration up, so the answers are C and D. Well, they certainly don't have the same mass. The feather doesn't have a greater mass. The weight of the elephant, force of gravity is so much greater, air resistance has less effect, so that's the answer. Acceleration of gravity, no, the acceleration is the same. The G is the same for them. And the elephant does not experience a smaller air resistive force, so it should be just C. So terminal velocity means no acceleration, and that has to mean that the net force is 0. So the only one that works here is object D. Oh, here's the one that I messed up on. So anyway, it's accelerating up because the net force is up, and it continues to fall but slows down. Okay, an object in terminal velocity is no longer accelerating and its speed is not changing, so that's C and D. So logically, greater speed will mean more air resistance. Bigger object pushing on the air, more air resistance. And also, if the density of the air increases, there's more air to offer air resistance. So as the skydiver speed increases, air resistance is going to increase, and as air resistance increases, the net force and acceleration will decrease. Even though the speed is increasing, the acceleration is decreasing. It's important to make that distinction. So B is the answer. Good. Completed another one. One left. Okay, last mission. Answer this question and then come back. So the important thing about Newton's third law is it tells us that the force is always equal and opposite. So the force on the bug and the force on the bus is the same, but the bus is so massive, its acceleration is negligible, whereas the acceleration of the bug will be huge. And so the correct choice is H. The forces are equal to each other, but the acceleration on the bus is less. The sprinter pushes on the ground in order to go forward, and the ground pushes back, right? If there were no traction or ice, the ground wouldn't push back, and the sprinter's leg would just slide out. So the force is equal and opposite between the sprinter's shoe and the ground. Okay, see if you can pick out the right answers without looking at mine. But you see what I picked? B. The bird pushes down on the air pushes up on the bird. The force of the earth on the sun and the sun on the earth have to be equal and opposite, but the earth is much less massive, so it affects its motion or its acceleration much greater. So the earth has a greater acceleration, but equal forces, that's letter E. Linebacker exerts a force on the fullback. The force of the fullback on the linebacker is equal and opposite, letter D. Fred pushes Harry. Harry pushes Fred. Pretty easy. As always, the forces are the same, but the more massive truck experiences less acceleration. So letter F. Catcher's mitt exerts a force on the ball, pushes backwards on the ball. The ball applies a forward force. The ball pushes on the mitt. Forward force, so A and E. So like the last example, the ball pushes on the catcher's mitt and the catcher's mitt pushes on the ball. They're two different objects. So although they're equal and opposite, they're acting on different objects. And so action and reaction forces are on different objects, letter E. Fish pushes on water, water pushes on fish. Once again, A and E. Okay, we're done. I'll put in the table of contents. There it is, table of contents.